You don't have to worry about it, right? Just split them into, or use your bit values up here to turn them into a decimal. Now, so I was going to show you how I know that consecutive bits on. We're used to using for subnet masks, right? In IPv4, 255, 255, 224, 0, 255, 255, 240, whatever, or whatever that you're using. So it's consecutive bits on. So I have a little table. I call it the bit to decimal table. All right. So you got 1 bit, 2 bit, 3 bit, 4 bit, 5 bit, 6 bit, 7 bit, 8 bit, no, something like that. No, just kidding. All right. So 1 bit on. What does that mean? 1 bit. Okay. That's 128. 2 bits on. That means 128 and 64. It's 192. 224, 240, 248, 252, 254, and 255. You need to know this. What does that mean? Let me show you the binary. These are consecutive bits on from right to left. 1, 2, 3, 4, 5, 6, 7, 8. Let me count that again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, all right. 1, 2, yeah. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And then all the way. And this is going to be extremely important to you when you're converting a dotted decimal numbering mask, or into, let's say, Saturn notation, or I should say the other way around, a Saturn notation into dotted decimal. All right. Now this will help you to understand, to know, when you're adding this way, you know what's what. If you have consecutive bits on, you know what they are, and then it's a lot easier. Okay. But it was the case where they used to give you an IP address in binary, and you need to say which of the following, right? They'll give you in the question a binary number, and then in the answers it was the dotted decimal format, okay? Or they gave you, a binary or a decimal, and you had to turn it into hex. That used to be the case quite a bit way back in my day. They're bringing that back because of IPv6. That's how you need to understand IPv6. That's why you can get 340 undistilling addresses. Okay. All right. So that's how I know that this is, 192. This is how I knew up here that 3 bits is 224. There's your 224. That's how I know this, right? But you need to learn your hex table. You need to learn your hex table. We know 0, 1, 2, 3, 4, 7, 8, 9. I mean, it is. That's what it is. It is. And A, B, C, D, E, F. But. Okay. Know that still, even 9, right? It's still, okay? Because there's a difference between 0, 9 and 90, right? Or 90, right? Because, and let me show you the difference. I mean, you probably already see it already. Bit 0, 9 means 1, 2, 3, 4. And then 8 would be 8421 would be 1001. So this is 8 and this is 1. So this would literally be 0, 9, right? And then let's just put the bit values so you can have a visual. 8421, 8421. So you added 8 and 1, okay? So if you go 90, I mean, you see it right there. It's the complete opposite. Let's copy paste this. Control C, Control V. Now it's completely the opposite. It's 0, 0. And this would be 1, 1, right? So, and let's put their value right up here, 9, 0. So what does that really change? Yes, it does. Yes, it does. Especially with, when, I don't know, we're not going to talk about voltage or anything like that, but when we're talking about IPv6 addressing, there's a big difference between 0, 9 and 9, 0. Because you also see this quite a bit in IPv6, and I'll put it in the center, okay? They love to do this. 2001, okay? DB8, 8, colon 1, and then they could, well, I'm just gonna put a 64 just for the heck of it, but normally they'll put a 128, the whole thing, like a 32-bit for IPv4, 128-bit for IPv6. Well, they'll do that. What does that mean? Does this mean 1, 0, 0, 0, 0? Nope. And what happened here? I thought we needed 8 sections in IPv6. So what this address really means is this. Let's do it from here. It's 2001 colon 0 DB8 colon 1234 1234. That is the network prefix of the address. Then we go to the other side. 1234 1234 1234. You see, we got 1, 2, 3, 4. Okay, one more set here. 1, 2, 3, 4. That's what that means. This is the shortened short version of this expanded version of the IPv6 address. But you need to understand that this one is this right here, okay? And that this right here in the network prefix side of the address, that is your 0 subnet, okay? So this is very important now to understand because your hex, right? Your hex, because we're in IPv6. And soon we're going to be in ISIS. And ISIS, the end sub address, it's also in hex numbers. So we need to work with it. It needs to be familiar to our eyes. So taking simple decimal numbers, you don't got to get crazy. And you got people going, well, what's 2,389? It's like, why? Why? Don't do that, okay? Just take a simple hex number. It's no bigger than 255. And if you can go ahead and convert it, or if you wanted to, take your MAC address. Take the MAC address of the PC, okay? And just put it out there, okay? That's why they, and convert them from hex to binary to decimal, and then take a decimal from decimal to binary to hex. And let me show you a very simple, very, very simple number, which they explain to you in your networking, Network Plus, and in your CCNA for layer 3 broadcast and layer 2 broadcast. So you got 255.255.255.255. Well, what is that in binary? Well, that means that all these bit values, 128, 64, 32, 16, 8, 4, 2, 1 are on. So in binary, that would be 1, 2, 3, 4, 5, 6. What happened? Try it again. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? Because the bit values, 128, 64, 32, 16, 8, 4, 2, 1. If you add all these up, it's 255. So this would be your layer 3. Now, how do we get that to a hex value, which is a layer 2 broadcast? Well, you split these two in 4 sections. So that means that and if you have them all on, well, I'm going to show you. So let's copy paste this and I'll put it down here. So you can see how we work that out. All right, so we're going to do here, space, 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 space. Yeah, I'm going right there. All right, so we got 2 spaces here. We got 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1. That is the value for hex numbers for 8, 4, 2, 1, 8, 4, 2, 1.